I'm Michael Sanders.
I'm Hongyan Lin. And I'm Marina Becker. We're at Team MHM and we're doing Project 3 on Steganography.
The flattening function we created is designed to take one of the images selected by the user and divide into two values, dark and light, by comparing it to a preassigned threshold, which is in this case 127. Any of the original values that remain true against this threshold will be assigned a light value of 1. Any value that returns false will be given a dark value of 0. The result is then placed into the output new image. The expanding function we made receives the output new image from the flattening function and converts it into a RGB image by turning the 1s into black pixels and the 0s into white pixels. It does this by first converting the new image from a logical type into a double type. Then it takes this converted new image and changes it into a grayscale image. Lastly, it creates the RGB image by co-concatenating the grayscale image. This new output is then stored into new RGB image.
So there's a few functions that go into the embedding and the recovery of the images, and I just want to run through those really fast and tell you how they all work. The nitty-gritty details can all be found in the write-up, so this is just a quick overview. So you can see the first thing we have is we have to read in the dog image, which is just this image that we're hiding other images in, so there it is. And then we have to run the dog image through the first function, which is called embed prep. If we take a look at embed prep, you can see it does a few things. It makes all the values in the image even, and the RGB values even. It makes division by 2 of those values also even, and it also makes them all divisible by 3. This is so that the embedding function can change these values to something else, and the recovery functions can check what has been changed and use that to recover the image. So here we're going to take new image, which is run through embed prep, and it's going to return it. These values have been slightly modified, but as you can see, it looks the same. Here we're just reading in and flattening out all the images using our image flattener. So here, let's take a look at flat 1, because we're going to be recovering this first. There's flat 1. You can see it's a Kemper Hall area map. Now we're actually getting to the real embedding functions. This is embed odd. You can see it takes this modified new image, and it's also going to take flat 1 in a color channel that you want to embed this on. The way embed odd works is it goes into the color channel that we specify, so in this case it's red, of new image, and it changes the values of flat 1 to odd. So when a recovery goes through, it can look for all the flat values, and those ones are flat 1. Now this is going to return test 1, which we're going to use and run through all of our other embedding techniques so we can show how they all work together. So the next one is embed 2 division, which changes dividing by 2 values to odd instead of even, how they had been in embed prep. So we're embedding flat 2 onto the red color channel. Then we're going to take this and run it through embed 3 to embed flat 6 also on the red color channel, so all 3 will be embedded. Embed 3 works by changing values to not be divisible by 3. Embed alpha is a little different, and I'm going to talk about that later, because it doesn't directly change the color values the same way that the other 3 do. So now we're going to write our file. We named it tester.png. We can see tester.png here. It has all 4 values hidden on this red color channel, but as you can see, the dog still looks basically the same. So now we can go in and use our recovery methods to get all of these off of the red color channel. You can see the recovery methods take this saved image that we're reading back in and a color channel to look on. Recover 3 division again checks for values that are not divisible by 3 and uses that to be the hidden image. So if we go ahead and run this, we can see we're going to get flat 6 out. So if we take a look, there it is. We have evil villain Bob. Same thing, if we'd rather recover using 2 division, using the same image, we can go ahead and run this, and we have our Geet Hall. And of course, we can run our recover odd, and we can get our Kemper Hall area back that we originally talked about. So our last embedding function is called embed alpha, and it works by hiding the image on the alpha channel. Again, this is different because it doesn't directly modify the RGB images. The dog image that we originally read in didn't have an alpha channel, so we give it one here just in case we decide not to actually embed anything. It will have a transparent alpha channel. In this case, though, of course, we do choose to embed on the alpha channel. We do this by changing some of the transparency values to 254, corresponding to the values in flat 10 instead of 255, so they're not quite as transparent, but you can't visually tell that it isn't transparent. Again, if we take a look at this image, you wouldn't be able to tell that there was a transparent layer that had slightly not transparent parts in it. It just looks like the dog. But of course, the computer can tell, and if we go in and recover A, we can look at our last recovered image, which is our secret agent checklist.
Hi everyone, this is Marina, and I'm going to take you through a quick little overview of how our GUI code was constructed and how to interact with our GUI. Here in the MATLAB workspace, we have the current folder set to our directory containing all the files we need to run our GUI, so all our hidden images, our starting image, and all the functions that operate to make the GUI function how it's supposed to. Our GUI.m file is the file that you actually run when you'd like to use the GUI. It consists of a lot of small functions which are generated using the GUI tool guide and are edited by me to execute the functions that we have separately written. Guide allows you to create a blank GUI and then mess with it how you'd like and add objects and other fancy things that you'd like to add. So these buttons on the side let you drag things like axes, buttons, drop-down menus onto your GUI, and then when you double-click on them, you're able to access the property inspector, which lets you view and edit many of the properties of these objects, such as font, color, visibility, and many other things. And once you have this sufficiently edited and you've created sort of a skeleton GUI code that has these empty functions generated inside of it, you're then able to go in and edit them to execute the sorts of things you want to do when the user is interacting with your GUI. So let's just take an example of some of our embedding functions. Function pushButton for callback was generated by the GUI tool guide, but all of this code in here I added so that on the callback of this push button, so when the user clicks on push button 4, all of this code will execute. So basically the image file will be embedded using an image embedder that we wrote separately. You can see those functions are over here in our workspace, and then it'll show it in another location. So I've edited this auto-generated function in order to have those capabilities. But for a little bit of a better example, let's go ahead and actually run the code using the run function in the workspace on the GUI.m file. This little window here is just a little bit of instructions on how to use our code. There's more in-depth instructions in our report, and also I'm going to give you some of these things as we step through it together. This is our GUI, and I'm going to go ahead and take you through an example where we load all 10 images into our normal image using all 10 embedding techniques. So first you're going to want to load up your starting image. We're going to use the dog, which we were provided, but you could use any 400 by 400 pixel PNG. And we're going to load each hidden image by selecting it from the drop-down menu. And like I said, you load it, and then you can choose a embedding technique. And I mentioned that we're going to go ahead and do all 10. So we're going to start with this first one here. And you can see that when the embedding is successful, a little bit of text pops up and lets you know that that is the case. And then you go ahead and you load up your second image, and the text goes away, letting you know that you have not embedded that yet. So hidden image 2 has now been embedded, hidden image 3, and so on and so forth. It's worth noting that you could embed the same image using all 10 techniques if you would like to. However, if you try to embed multiple images using the same technique, you're going to run into the problem of interference, and your recovery is not going to look how you would expect. In fact, it's not really going to look like much of anything, and you're going to be very disappointed. So do not try and use the same and try and put multiple images into the same embedding technique. Okay, and the last hidden image that we're going to load in is hidden image 10. Embed it, and now we're going to go ahead and we're going to save it. We're just going to call this file test file as our example. You can save it wherever you'd like. I just saved it in my current working folder. Alright, image has been saved, so we can load it back in. You just select it from your file structure. And then each recovery method corresponds to the embedding method that was used. So as we progress through these recovery methods, you can see that we're recovering the same images that we embedded in the same order. And I did them sequentially just for ease of visualization and keeping track while I'm talking. However, you can embed them using any order. Any image will work with any embedding technique. Like I said, the only rule is that you cannot embed multiple images using one technique, but any image will work on any one technique. So that's it. That's pretty much just a quick overview of how our GUI works and how you can interact with it. I hope you have fun playing with it, and for more information, please check out our report. You can watch this video again and again to try and get a better idea if you need any help, or get in contact with us. Hope you've enjoyed our program. Thanks.